All right, so now I really want you to take notes and pay attention to this because this is the most important stuff that you'll have to do when it comes to using these meters. Okay, there's very specific rules on when you use them and how you hook them up to the circuit. And I want you to create a reference document that helps you remember these things because you'll be doing these things in the future. If you do the wrong thing, you'll hurt the meter or you'll get a fake reading. Okay, so let's look at these things. When checking for voltage, the leads are placed in parallel with the circuit with the power on. All right, so if you look at this picture, you'll see the circuit's totally intact. We leave the positive on the battery, we go through a resistor, we go across the top, we come down to a motor, we come back to the battery. In no way are we opening the circuit. The circuit stays totally intact and we touch it from the outside. The reason why we say it's parallel is because our meter is in a complete circuit from our 2 points. It has power on one side of it and ground on the other side of it. Therefore, it's another circuit within our circuit. We just touch wherever we want to touch. Remember, with a voltmeter, we are comparing the 2 points. Measure from positive to negative, we should get full battery voltage, right? Because that's the difference. One is touching 12 volts and the other one's touching ground. If we touch it within the same circuit, the same line right here, this is ground and this is ground. So what's the difference? They're both zero, so it should be zero. Okay, so when you're using a voltmeter, regardless of what you're using, if it's on V, just keep in mind it's comparing those 2 points, no matter what it is that you're measuring. Okay, when we're using a multimeter to check resistance, the leads are placed across the component with the power off. 2 steps, always 2 steps. Number 1, turn the power off. Number 2, isolate the item. Okay, if you heard in that video, he mentioned that you have to remove the item from the circuit board to measure it. Let me explain to you why you have to have the power off. We mentioned that current flows from a positive point to a less positive point, right? This meter has a very small battery in it. When we go to measure resistance, the meter completely opens itself up with no defenses, right? It wants to measure the slightest, tiniest bit of resistance. Therefore, it has to totally open itself up so it can pick up the tiniest little thing. The way it does that is it sends an AC voltage through it. It sends the AC out, it goes through the resistance, and the amount returns back tells it how much of resistance it just went through, by how much voltage was lost. By using a tiny amount of voltage, the giant 12 volts that are, or 5 volts or whatever voltage is there, just barrages that meter and blows the fuse in the meter or blows the meter up. Okay, so very important. 2 things. Power off. Notice that the fuse is out, but switch off, fuse out, whatever. And then the item we're measuring, we want to remove that from the circuit so we only get the resistance of that item. Power off. Isolate the component. Never test resistance with the power on. Notice I say this twice. If the resistance of the component is unknown, start with the lowest range setting and move up until you get a good reading. Our meters have auto ranging. If you plug them in, they'll settle themselves out wherever it is. If you go too little, you'll get OL, which means out of limits, right? It's out of its ability to display. So then bump your stuff up. So go from checking 10 ohms to 50 ohms to 100 ohms to 1,000 ohms, and just keep going until that OL gives you a reading. If you go too far and it becomes too big, it's going to round out and it's going to settle out. So let's say it's 760 ohms. It might round to 800. So you want to always have it be in the working range of whatever that resistance is. Calibrate the meter for each use. So if you are measuring very small amounts of resistance, very small, the leads themselves have resistance in them. You have a little delta symbol on that meter, and if you press it, it zeroes out the resistance. You hold the 2 leads together, so now it shows 0.1 or 0.2 ohms. Hit that button, it goes to 0. Now what happens is you can't measure something really big once you've done that, because it won't auto range out of that. If you're measuring 10,000 ohms, 0.2 ohms isn't going to make a difference. If you're measuring half an ohm, 0.5, then 0.2 makes a big difference. Okay, so if you're measuring something tiny, you calibrate it by zeroing out the meters, the leads. If you are measuring something big, don't worry about it, it won't make a difference. When checking amperage, the leads are placed in series with the circuit with the power on. So if you notice here, we break the circuit open, positive goes to the most positive side, negative goes to the most negative side. The meter's only protected for 10 amps. If we do that with anything bigger than 10 amps, we'll blow the fuse in the meter. So it's very important never to overload the circuit, higher than 10 amps when it's going through the meter. What do we do if it's bigger than 10 amps? We use an inductive meter, and we'll have one of them in a second. Okay, so in series means the circuit now goes like this. Okay, and it'll capture whatever is passing through the section that you interrupted.